Okay, so chi-squared. Um, yeah. So let's see. Chi-square test is used with count data to test
Mm-hmm.
how well it fits some expected distribution. Okay, the most common use of chi-square statistic in statistical practice is with R cross C contingency tables to assess whether null hypothesis of independence among variables is reasonable. Okay,
Mm-hmm.
so yeah, we'll see, right, what that means. Okay, so again, chi-square test, what we used is it for? It's used with count data, and we
Mm-hmm.
test how well it fits some expected distribution. Okay,
Mm-hmm.
all right. So original developed by Pearson, Carl Pearson, and this Greek letter is chi. Right? Okay, अब there's something called chi-square statistic, just like t statistic, f statistic, right? And we have a chi-squared statistic, a measure of the extent to which some observed data departs from expectation. A measure of
Mm-hmm.
which some observed data departs from expectation. And there's another term called expectation or expected.
Mm-hmm.
How we would expect the data to turn out under some
Mm-hmm.
assumption, typically the hypothesis. Like how would I expect the data to turn out under some assumption? For example, if it was null hypothesis, okay, how would our data look like? And that is
Mm-hmm.
expectation, okay? And
Mm-hmm.
DF is degree of freedom, right? Okay, and minus one thing. Oh, okay, okay, small difference, right? It's not okay here. The degree of freedom is R cross C, R time, okay, R minus one times C minus one. We'll see, right? Anyway. Okay, so R cross C means the R means number of rows times the number of columns, right?
Yep.
The 2 by 3 table has 2 rows and 3 columns.
Mm-hmm.
And here's an example. Okay, let's see. Let's analyze this example.
Mm-hmm.
Okay, suppose you're testing three different headlines,
Mm-hmm.
B and C, right? And you run them each on 1,000 visitors with the results shown in this one right here. Okay, so now let's see. Let's say headline A, headline B, headline C. There are 1,000 visitors, right? Okay, so headline A, okay, out of these 1,000,
Mm-hmm.
14 click on headline A, and the
Mm-hmm.
rest 986 they didn't click on headline A.
Yeah. Yeah. Yeah.
And likewise here, out of 1,000, 8 clicked on headline B, and the rest 992 did not click on headline B.
Yep.
Likewise, same thing here.
Mm-hmm. Yep.
When you look at headline, data headline, certainly they appear to differ. Any
Mm-hmm.
differences? Yeah, right? Okay, 14, 8, 20, 12. Okay, this is quite different from these two.
Mm-hmm.
And it looks like the headline A returns nearly twice the rate of
B. Yeah.
16, or nearly twice. Well, the actual numbers are small though, right? Okay. Okay.
Mm-hmm.
Sampling procedure can test whether the click
Mm-hmm.
differ to an extent greater than chance might cause.
Mm-hmm.
This is our test with chi-square test ligandinho, right? So
Mm-hmm.
what does chi-square test do? Let me highlight this before I forget it. Right here. Let me highlight this one. Yeah. Okay. A resampling procedure can test, right? Okay. Whether the click rates differ to an extent greater than chance might cause. And we'll see.
Mm-hmm.
Right? We'll actually see. Okay. For this test, we need to have this your test gonna play.
Mm-hmm.
Well, there is something called expected distribution of clicks. Expected.
Mm-hmm.
I think expected. Then there's this thing.
Mm-hmm.
Okay. So we'll actually do it, right? Okay.
Yep.
So expected distribution clicks, and in this case, that would be under the null hypothesis assumption that all three headlines share the same click rate
Okay.
for
Mm-hmm.
an overall click rate of 34 out of 3000,
Mhm.
right? So what we need to do is first we need to come up with expected
Mhm.
distribution. And
Mhm.
the real observed values for these are, right? So
Mhm.
if it were null, okay, if we
Mhm.
go with the null hypothesis, means they all are the same.
Yep. 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 Yep.
Means you have a total of 34 clicks, right? You think that's what you have a 34 clicks,
Mhm.
and the total is 3000, 1000, 1000, 1000.
Mhm.
Out of
Mhm.
3000, you have
Mhm.
34 clicks,
Mhm.
right? And
Mhm.
that means, so you got 34 clicks out of 3000,
Mhm.
and if you distribute, right? Okay. So
Mhm.
under this assumption, I'll continue. Okay. So that means, okay, we're going to distribute. Okay.
Mhm.
So this, if they are all equal, right? So you would divide 34 into equally into three parts,
Mhm.
11.33. If you add them up, you should get close to 34.
Yep. Yep.
So basically, we spread 34 equally,
Mhm. Mhm.
so that now this is the expected, right? It means null hypothesis. If the null was true, right?
Yep.
Null were true, this is what
Mhm.
be like. And the
Mhm.
rest, 1000 minus this is this, 1000, and okay? 1000 minus 11.33, UIO, this and this, they are all the same, right? Okay, now we have the observed and the expected, right? Okay, now we're ready to compute the something called Pearson residual.
Mhm. Mhm.
Okay, and Pearson residual, the formula is R is equal to observed minus expected divided
Mhm.
by square root of expected, right? Okay,
Okay.
and this is the formula, and we can use this formula to come up with something called the, okay, Pearson residual stable, and this is the Pearson residual stable. Okay, and how did we get these numbers? Okay, now so we just use that formula,
Mhm.
right? Say, for example, I have shown you here. It's normally used, right? Say, how did you get this? How did we get this number?
Mhm.
Observed. In this case, what's the observed? Observed 12, right? Minus expected, this one,
Mhm.
correspondingly, right? Headline C को click on the
Mhm.
12 minus this 11.33 divided by the square root of 11.33, right? Which is
Mhm.
right? 12 minus 11.33 divided by the square root of 11.33, and you get that. It's
Mhm.
similarly here. It's one thing.
Mhm.
You can see that. Like, for example, headline B, 8
Mhm.
minus 11.33 divided by
Mhm.
square root of 11.33 should give you this one right here.
Okay.
Okay. And so on. Hey, when we see now, this is the,
Mhm.
this table of
Mhm.
residuals, Pearson residuals. You like,
Mhm.
right?
Mhm.
Okay, what's the
Mhm.
next step now? The next step is finding the chi value. Okay. So, okay, so now, which is the chi squared statistic is defined as
Mhm.
the sum of squared Pearson residuals. Means
Mhm.
you add all of these together,
Mhm.
sum them all. Hey, ये सब पहले sum गर्यो भने you get chi. Actually, square and sum, sorry. Right?
Mhm.
Square all of them so that you can remove the, you don't get negative, right? All are positive. They got even. So we'll take, okay, this is R. We square the R, right? And we sum, right? Sum along the rows and along the columns. Along the
Mhm.
rows and along the columns means all of them. Right?
Mhm.
Okay. So along the columns, right? J is the column, I is the row. Okay.
Mhm.
So all the columns, all the rows. Right?
Mhm.
It's the compact, your notationally here, right? In effect, that is, you square each of these numbers and sum
Mm-hmm.
them. Continue. Right? And
Mm-hmm.
that is the chi value. Right? Okay. And we'll see. Okay. So, and okay, the chi-square statistic, for example. So if you actually, I actually compute, I mean, I did that. I added them all together and I got exactly this number. 1.6659 something किया कुछ थियो, but yeah, you round गरेर 666 हुन्छ, right? And if you add them up, that's what you get. Square and add, not add, but square and add. सबैले square गरेर add गर्यो भने actually I computed this and I confirmed that it's 1.666. Okay?
Mm-hmm.
And is that more than could reasonably occur in a test? So this is the value we got, right? Now,
Mm-hmm.
okay, that's the value we got, right? Now, what about the statistical test, statistical significance test?
Yeah.
And is that more than could reasonably occur in a chance model, right?
Mm-hmm.
त्यसको लागि we can test this with resampling,
Mm-hmm.
okay? Resampling algorithm. Okay, so let's see how that goes here. Okay, so now we can test. Okay, so let's see. To simulate this, hey, it's only 34 clicks out of 3,000, right?
Okay.
Okay, so what we do is so we put in one box, means we have in programming, it's just one, it's a big list, right? Where there are 34 ones, right? One, 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 so sort of, okay, baki out of 3,000, minus 3,000 minus 34 is this one, 29,2966 zeros. That is simulating no clicks,
Yeah.
right? Total of 3,000 data. Out of those 34 are ones representing clicks,
Mm-hmm.
2,966. There are zeros, which are representing no clicks.
Yep. Yep.
Right?
Yep.
And we shuffle them. Okay, but mix the shuffle.
Mhm.
And we take three separate samples of 1,000, random sampling.
Okay.
Right? We take three separate samples, random samples of 1,000, and we count the click in each.
Mm-hmm.
Right? And we find the square difference between the shuffle counts and the expected counts and sum them.
Mm-hmm.
Right? Square difference between the shuffle counts and we have the, of course, expected count just like in the previous table, right? And so we sum them and we repeat this step, maybe say 1,000 times, okay? And we try to see how often does the resampled sum of square deviation exceed the observed.
Mm-hmm.
That is the p-value, okay? So now, how often, है जुन हामीले यहाँबाट जुन निकालेको छ नि,
Awesome.
है square difference between यो छ नि, okay? So how often this square difference, okay, यो पनि त chi squared हो नि त, है chi है, अब यो चाहिँ कतिचोटि त्यो यो हामीले कम्प्युट 1.66 आयो नि त्योभन्दा बढी कति टाइम्स आयो त, what is the
Mm-hmm.
frequency, right? And that is the p-value,
Mm-hmm.
okay? Means the probability that you get that difference, sum of squares deviation, right? And that is the probability of getting that kind of result, or that kind of result, uh, if the null distribution were true,
Uh-huh.
null hypothesis were true. Okay, so basically, okay, you just count the number of times out of 1,000. How many times did this value, the square difference value, Sunny, how many times did it exceed 1.666 that we got?
Uh-huh. Yeah. Okay.
And that's all. And then, so that number of times that exceeded, equaled or exceeded, right? And that is the p-value. And here, okay, that is the idea. But uh, in R, you can very quickly do that. Right? You
Yeah.
have सबै step by step गर्नै पर्दैन है, यो चाहिँ त्यो स्टेप्सहरू यस्तो हुन्छ भनेदेखिमा चाहिँ तर all you need to do is, okay, call this function
Yep.
csisq dot test, right? And clicks, okay, clicks, and then you clicks is the data. You just provide this data, this observed data, right? Clicks, and simulated p-value equal to true. And here you get exactly the same number that we found up there, 0.6659, right? Which is math is 1.6663 only.
Mm-hmm.
Okay. So yeah, we got the same. The any number by any right?
Mm-hmm.
Through programming, right? Through this function call. And we don't need df, so this, right? And the p-value here is 0.48.
Yep.
But if you see now, it's a big p-value, right?
Let's see.
So that means it's not statistically significant.
Yep. 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 Yep.
Okay. So yeah. Our U now we see, the way we can compute chi-squared, right? Using the, you know, manually or assembly, right? Yes, assembly manually question निकाली so that we really understand what's going on. And
Mm-hmm.
we saw the same thing, how we can compute with just one line of code in R.
Mm-hmm.
And we have interpreted the result. And we got the same number as computed by our manual method, right? Okay. And this P चाहिँ यो यसबाट आएको यो step 1 2 3 4 छ नि यसबाट चाहिँ P value निस्क्यो okay, based on 2000 replicates.
Mm-hmm.
Okay. So now, yeah. अब now there are other ways to compute chi-squared, right?
Mm-hmm.
This is one of the ways, which is the manual way. Hey, I'm just manually going to. And another way is by using degrees of freedom.
Yep. Okay.
So let's see another way. Asymptotic statistical theory shows that the distribution of chi-squared statistic can be approximated with something called chi-square distribution.
Mm-hmm.
Okay, it's called chi-square distribution graph. Okay? And we can use that chi-square distribution graph and quickly we can find the p-value directly from the graph without doing any of these.
Mm-hmm.
Right? Okay, the appropriate standard chi-square distribution. Okay, so it's using the degrees of freedom.
Mm-hmm.
Okay, and here the degrees of freedom is defined as r minus 1 times c minus 1.
Mm-hmm.
Number of rows minus 1 times number of columns minus 1. Okay, and here it is. And this is the chi-square distribution with various degrees of freedom. X-axis has degree of freedom, and here is the p-value.
Mm-hmm.
Or rather, let's see, probability on y-scale. So here's the probability.
Mm-hmm.
That is the p-value, right? P-value, and here degree of freedom. And what is the degree of freedom? R minus 1 times C minus 1. Okay, so हाम्रो यहाँनिर degree of freedom के हुन्छ? How many rows here? 2 rows. 2 minus 1 is 1. होइन? 2 minus 1 is 1. R is 2. Click on R equal to 2. होइन? When you say R equal to 2 minus 1, okay, R minus 1 is 2 minus 1, which is 1,
Mm-hmm.
times होइन? C minus 1. C, there are
Mm-hmm.
3 C's. Column 3 center. 1, 2, 3. 3
Mm-hmm.
minus 1 is 2.
Mm-hmm.
So our degree of freedom is 1 times 2.
Mm-hmm.
Okay? And our DF is 1 minus 2, which is 2. Right? So now we can go and look up this thing. So we're going to look at DF equal to 2, which is here. And that is probably this one right here. Your graph हेर्नु DF2 सँग related graph. Your chi-square graph. This is chi-square distribution graph, right? And you're going to look at 2. Value 2 is the यहाँनिर somewhere. So it's a pretty big value, see? माथि छ
Mhm.
होइन 0.3 भन्दा सी अफकोर्स यहाँ चाहिँ 0.43 छ नि त द्याट मेक्स
Mhm.
सेन्स 0.2मा इफ यु गो अप हियर इन दिस ग्राफ यु गेट
Mhm.
समथिङ लाइक या मोर देन 0.4
Mhm.
यहाँ माथि होला नि त है ओके सो एन्ड इट चेक्स आउट होइन
Mhm.
matches what the the this is telling you right okay यसले दिएको हामीलाई के छ p भ्यालु 0.4348 छ df2 दिएको छ है
Mhm.
r minus 1 times c minus 1
Mhm.
अनि त्यसबाट यसमा हेऱ्यो ठ्याक्क गर्दाखेरि मिल्छ
Mhm.
है ओके सो नाउ दिस इज ग्राफिकली गर्न पनि मिल्यो है ओके अब there's still one more that we call fishers है fishers exact test भन्ने छ है अब यसमा चाहिँ यसले चाहिँ अझै मोर एक्युरेट भ्यालु दिन्छ यसले है
Mhm.
exact test है The chi-square distribution is a good approximation of the shuffle resampling test है
Mhm.
chi-square distribution test है यो है
Mhm.
It's a good approximation. You saw that right? Quickly, right? Without doing much computation. Right? All you need to figure out is the DF, which is R minus 1 times C minus 1. Very simple. Okay? And it's a good approximation to the shuffle resampling test as described in Matiko. Step 1 manually गर्यो except when counts are extremely low. Right?
Mhm.
So when the counts are low, of course, right? But in such cases, the resampling procedure will yield more accurate p-values. Okay. So so if your counts are low, right, your resampling procedure will, you know, yield good bad p-values, and you can use, of course, this one. In fact, most statistical software has procedure to actually enumerate all the possible rearrangements that can occur, tabulate their frequencies, and determine exactly how extreme the observed result is, right? Okay, there is statistical software, yeah, that's what they do, right? They use the permutation, right? And that is called the Fisher's exact test, okay, after the great statistician R.A. Fisher, okay? And this is how you're going to use it. Fisher.test clicks. And this gives you exact value or more precise value, maybe 0.4824. It's very close to 0.4348, right? Okay, you have that. Your Fisher's test is
Mhm.
more, if you want more, precise. Okay, all right. So p-value very close to the p-value of 0.4853.
Mhm.
Is the resampling. Oh, resampling is 0.4853 दिएको रहेछ. Let's see. 0.4853 कहाँ थियो? 4853 यहाँ माथि होला. Yeah, this one. See, this is very close to this. Okay. So,
Mhm.
and yeah. Okay. Yeah. And then it takes okay. So our next time what we're gonna do is we're gonna cover this multi-arm bandwidth bandit thing, multi-arm bandit algorithm. And after that, let's say we can enter now something called regression, a regression, your prediction or something.
Mhm.
This is अब हामी प्रेडिक्टिभतिर जाँदैछौँ कि
Mhm.
predictive analytics है regression we'll start with simple linear regression देखि है एकदम फन्डामेन्टल कन्सेप्टहरूबाटै we'll start है अनि यो भयो and we'll do regression equation भइहाल्यो है अनि okay residuals yeah है and least squares regression पनि गर्छौँ
Mhm.
and prediction versus explanation. Okay, so and likewise, RMSC okay, we'll look at metrics in a metrics भन्छ regression metrics we'll look at regression metrics. Okay, R square statistic R square cost validation these are यो सबै machine learning हो क्या अब चाहिँ हामीले जुन टपिक्सहरू छ these are more data science machine learning, right? More Regression is itself a machine learning, right? Pretty machine learning person, right? And okay, and probably we can do some classification as well, right? Classification. So yeah, so more interesting topics coming up, right? Apart
So,
from
sir, is that okay if I share one of the projects for the chi-square test and like, can you give some insights into this?
sure, sure, हुन्छ,
म
sure.
एउटा अर्को ल्यापटपबाट हजुरलाई जोइन गरौँ एकचोटि आई क्यान सेयर माई स्क्रिन
Okay, हुन्छ, sure. Okay,
म
so
कुन चाहिँ यसमै जोइन गरौँ कि अरू अगाडिकोमा जोइन गर्नु
यसो गर्दा हुन्छ, you can send me the file or something, त्यो मिल्छ भने I don't know के छ।
त्यो एकचोटि नमिले एकचोटि सेयर मात्रै गरेर एकचोटि
ए
मिल्छ कि भन्ने गर्छु।
हो,
अर्कोमा जोइन गर्नु तपाईँको टाइम छैन भने अर्को नेक्स्ट टाइम पनि गर्न मिल्छ हामी अहिले
यस्तो
आजै गर्नु
नेक्स्ट टाइम गरौँ कि आज यहाँ अलि
ए
ढिलै
हुन्छ
भयो।
हुन्छ डेफिनेटली हुन्छ सरी सर नेक्स्ट टाइम
किन
एकचोटि म तपाईँले त्यो हाम्रो क्लासको सुरुमा चाहिँ तपाईँले बुझाएको तपाईँले काइ स्क्वायरको बुझाउनु भएको र यो लाइक इट्स टोटली सेम हुन्छ लाइक आई टोटली अन्डरस्ट्यान्ड द्याट तर दे आर लाइक सम न्युएन्सेस लाइक यो स्याम्पल साइज क्या लाइक ट्राइङ टु क्यालकुलेट इफ द डेटा इज स्याम्पल साइज इनफ अर नट अनि लाइक यो यसमा चाहिँ हामीले पेयर वाइज पनि गराएको छ सो आई जस्ट वान्ट टु मेक स्योर द्याट इफ आई क्यान यु नो अझै यसलाई राम्रो रिडिफाइन अझ रिमोडिफाई गर्न सकिन्छ कि तपाईँको कुनै इन्साइट छ भनेर आई जस्ट वान्ट टु मेक स्योर त्यसले गर्दाखेरि लाइक नेक्स्ट टाइम इफ यु क्यान स्टार्ट विथ माई प्रोजेक्ट एन्ड लाइक दिस यु क्यान गिभ सम इन्साइट्स टु दिस द्याट वुड बी ग्रेट सर बिफोर वी स्टार्ट सिन्स वी आर स्टिल इन काई
हुन्छ,
स्क्वायर यु नो
sure, sure. मेबी तपाईँ जति केही सेयर गर्न मिल्छ भने जुन जुन सेयर गर्न मिल्छ मेबी
हजुर
स्क्रिनसट or जे होइन यसो जुन विच
ए
यु क्यान
डेफिनेटली डेफिनेटली म हुन्छ सर म हस् हस् म
so that I can take a look before the next class,
अफकोर्स
है
अफकोर्स म त्यो हजुर म मिलाएर सेयर गरेर हजुरलाई
हुन्छ,
पठाइदिन्छु थ्याङ्क यू सर
है ल
थ्याङ्क
हुन्छ
यू सो मच
ल थ्याङ्क यू, so see you next time then, है ल बाई।